Hi friends, welcome to my channel. Today's video is going to be about lunar libration. We know that the moon is tidally locked, and that doesn't mean we're just going to see the 50% of the moon's surface. The moon is tidally locked to Earth, meaning it rotates on its axis in exactly the same it takes time to complete one orbit around Earth. This is a synchronous rotation, and it typically represents the same phase to Earth. However, due to several orbital characteristics, we can actually observe approximately 58 to 59% of the lunar surface because of libration. We have libration in latitude and libration in longitude. Today, let's talk about the libration in latitude. Libration in latitude has one case, and that is the axial tilt. So the moon's rotational axis is tilted approximately 6.7 degree relative to the normal of its orbital plane around Earth. As you can see right here, it is the moon's orbit, and it's the orbit. It is not clearly shown here. So let's suppose this is Earth, this is moon, then suppose it like they are tilted at 5 degrees, okay, then along with the moon's axial tilt of 1.5 something degree, we have 6.7 degree. This is analogous to how Earth's axial tilt causes seasons. The maximum libration in latitude is approximately 6.7 degree. So when the moon's north pole is tilted toward Earth, we can see more of the northern lunar surface, and for the south pole, vice versa. So let's go on this topic. As a result of libration, we can say this is this. Let's estimate the maximum angle of libration in latitude, which is we know it, right? The axial tilt of the moon with respect to its orbital plane, done. So now we need to approximate the maximum angle of the libration in longitude. Libration is longitude is because of the orbital eccentricity. The moon's orbit around Earth is elliptical rather than circular, with an eccentricity of approximately 0.0549. So according to the Kepler-2 law, the moon travels faster at perigee and slower at apogee. So however, the moon's rotational speed remains constant. So the maximum libration in longitude is going to be plus minus 7.4 degrees. So as I told you, the mechanism, moon is moving the fastest in its orbit near the perigee and lags behind in the eastern limb, while slowest in the apogee and revealing more in the western climb as it gets ahead. So for the second question, the first question answer will be, of course, this equals alpha equals 6 degrees. My board got destroyed. No problem. Let's focus on this. We have 6.41. That was scary. Okay, let's focus here. The maximum angle of libration in latitude is simply equal to axial tilt, because libration in latitude occurs because moon's rotational axis is not perpendicular to its orbital plane. So the maximum libration in latitude occurs when the moon's pole is tilted maximally toward Earth. Right, this means we can see approximately 6.7 degree beyond the Earth's moon's north or south pole at maximum libration. So for example, we have Earth right here, then this, and we have moons. Okay, it is center of the moon, right? So we can see actually 6.7 degree beyond. So for the libration in longitude, we have for maximum libration it is 2 times the eccentricity. So each changes between 0.044 and 0.064. We know it's, we take the maximum value for the maximum libration angle, so 2 times this is going to be 0.128 rad. Therefore phi L is going to be 0.128 times 180 by just calculate it in degrees, maybe 7.33 degrees. So in fact of a geometrical one, suppose this is it, right, and you must happen to see this. So it's earth and this is moon, and you know this is A, B, C. I just happen to make this geometry of the lunar libration in longitude. Anyways, so for the solution, right here, determine the fraction of the moon surface which can be seen from earth. It is calculating how much of the percentage. It is just the proportion method. I will give it to you to do it. Okay, so it's going to be, it's just the proportion method. You can use this, put in the values. We have calculated 180 degree is the normal visible nominal visible hemisphere, while the x is the added percentage of surface area visible due to libration, and just calculate the value of x. It must be around 8 degrees, right? So that 8 to 9 degrees, and the total visible area will be 58% as you add them. And do we have other questions? Calculate how many months are needed for an observer to see the moon surface determined in part C. So it is just as, okay, let's do this. So we have 1 by t equals 1 by t draconic minus 1 by t anomalistic. You need to know the libration in longitude and libration in latitude. So the period of the draconic month is 27.212, while of this it's going to be 27.554. Just substitute the values, you will get a ty2 equals 1087 days. Convert it using synodic month, which is 29.53 days. You will get n equals 1087 divided by 29.53 as 36.81 months, and this is about 3 years for an observer to see the entire libration surface determined in part C. Okay, that's it. Thank you for today. If you have any confusions, you might ask and comment. I'll be happy to share more knowledge.